Hello, hello, my algebra friends. We're starting a new section. It's called Conic sections. What in the world is a conic section? Well, it's stuff that you see all over the place in your real life all the time. I mean, most obvious of all is the fact that we live on a planet, right, called Earth, and we orbit something called the sun. The big yellow one is called the sun, and that path that we take, called the orbit, is called an ellipse. It defines an ellipse, and so an ellipse is one conic section we'll run into. And actually, if you zoom in right here, you look at this, the moon takes an elliptical orbit around the Earth as well, so we see ellipses. How about this shape down here? Can you name that city right there? Maybe you've been there. It's St. Louis, the gateway to the West. That is the arches in St. Louis, and that takes a parabolic shape, and that would be a parabola is another conic section. Now, a parabola is something that you have run across before in a quadratic equation. If we graph it, it takes a parabolic shape. Parabolas are all over the place, and they're used in engineering, they're used in design, in structures. Their properties have been a great benefit to mankind throughout the ages in these areas. And finally, this is a supersonic jet over here, and that creates what you see happening is a sonic boom. And when a sonic boom hits the ground, it takes the shape of a hyperbola. Hyperbolas we'll get into a little more, but the hyperbola is the third conic section. So we have ellipses, parabolas, and hyperbolas. But why in the world are they called conic sections? I mean, we know parabola. Maybe you've heard of hyperbola. Ellipse, at least we're familiar with. Why aren't they called bolas or ipses or whatever they are? And in fact, there's one other conic section that we've left off, and that would be the circle. Circle would be the fourth one, but we've already visited those. Well, why are they conic sections? Well, that's because we take a cone and we intersect it with a plane. So here we see a diagram of two cones that extend infinitely. Just imagine in every direction. These cones go infinitely in every direction right here. And they're intersected by this yellow plane. And depending on the angle of intersection of this plane, we get the different conic sections. So if we look at the first example, up here at the top, that plane, that yellow plane right there, is perpendicular to the axis that these cones are aligned on. So it's perfectly perpendicular, and you can see that the yellow plane, when it intersects that cone, the shape, when it's outlined here, it's bent, but if you tilted that plane so it faced us, so if that yellow plane faced us like this, the intersection would be a circle. So that's our first conic section, is a circle. Now, the second one, what happens if we tilt that plane upward just a little? So from our circle intersection, we take that plane, we tilt it up just a little like this, and it intersects just the side of that cone. Well, in that case, we have a parabola. Now notice what that intersection looks like. If we tilt that plane upwards, our intersection looks like this. We have a smiley face right there. And that is a parabola. So we have a circle, and we have a parabola. And let's go up to the top here. Third one, we have circles, parabolas. Now what if we took that plane and we tilted it just a little bit? So we took from what a circle is and we tilted it just a little, not so much that it's going off the end of the cone, it's still within the cone. And notice what we get in that situation. We get a flattened circle of sorts. Again, if we took that yellow plane, drew it out, we would have a flattened circle, almost an oval, but the technical term is an ellipse. And it really is a circle that's been flattened or extended in one way or the other. You know, ellipses could go the other way too. We can have an ellipse this way in the same way that we can have a parabola that faces down, or we could have parabolas that go left or right. And finally, we have circles, parabolas, ellipses. Our fourth conic section is the hyperbola. A hyperbola. Now notice the difference between a hyperbola and the others, especially with the parabola there. In a hyperbola, that plane is tilted all the way so that it intersects both cones. so that if you drew that plane, it would have two pieces of the hyperbola. And the interesting thing about hyperbolas is their curves sit within two asymptotes that we'll see later. They never touch them. They extend on into infinity, but never quite touch, just like asymptotes. And these are your conic sections: your circles, parabolas, ellipses, hyperbolas. You've seen circles already. You've seen parabolas, but we're now going to look at them in a more analytic, geometric standpoint. So here's your intro. We'll be diving deeper into these as we go. All right, guys, I'll see you soon.